My name is Pablo Galindo.
And my name is Łukasz Langa.
And this is the Core.py podcast. A new podcast, well, I suppose it's not new anymore because we are over 10 episodes, where we discuss internals of CPYTHON and other adventures in making a new version of your favorite programming language. Well, not I know see, Łukasz.
Yeah, it's been a month.
Yeah, indeed. We are getting near to beta freeze, which is the time in CPython when basically the last minute frenzy to make sure that all features land appears, and everybody tries to get their feature pushed in the last second, and Billboard's broke and everything is on fire. So it's a nice time to, go to the fire that it will be the CI of CPython and have a warm time at night to tell horror stories.
Right.
And what best horror story to discuss that this feature that we are working together, which is our new shiny new interactive REPL. And we are going to talk about this because we're getting close to merge it in a way that will break all CIs in the planet.
Probably we won't break much CI because secrets, actually they have the tests that run the REPL tests mostly disabled due to some details that we're going to cover soon.
The old trick of disabling the test to pass the test. Do you work at...
that's the thing.
What was the company? BMW? No.
Volkswagen.
Yeah. Do you work at Volkswagen? Do you even Volkswagen, bro? Cool. This is actually a hairy thing, right? Like most people interact with the REPL and the terminal and whatnot, but many people don't really know the Lovecraftian horrors that lie beneath.
Right. Like that's one of those things that actually goes all the way back into the far past that nobody remembers anymore. So first of all, when we had like those massive mainframe computers, people had to actually be at them to do anything. But then the entire sense of them being multi-user was sort of crippled by them having a console or two or four or so. So this entire concept of terminals was created where you could actually have some dumb device that just looked like a typewriter. You could type commands into it and got results back, like with just being, literally printed back to you on a printer. So that was the terminal. And even in those times, we established a protocol that we use to this day for this sort of communication. And TTY, teletypewriter, is still what we call that protocol. So we can accept input from a keyboard and mouse, like that's a later extension.
Wow, the future. A mouse, what is even that?
So to this day, that's not universally supported everywhere. So, it's like...
It's kind of weird, right? It's like almost having Fallout technology around, right? Like clicking in the terminal and moving there. It's like, wow, like what is this? This is magic.
Yes.
But it's 2024.
Right. So on Linux and Mac, you will find devtty entries. If you look in your dev directory, like this pseudo directory that the kernel provides, and those are usually monitored by a Getty service or by the kernel in case of the Mac. So some of those entries are virtual terminals, but others are actual consoles for hardware that you have connected to your computer. Just recently, I got this RetroWave device, that tiny device that essentially allows you to connect the frequency modulation synthesis chip by Yamaha that early AdLib and Sound Blaster sound cards use. So you can actually just output this sound on a modern computer, and you do it by a TTY. Essentially, it is a serial interface that you communicate with. But obviously, this is not what we're going to be talking about today. What we're talking about is terminals, but actually they're not real terminals as we established. They're terminal emulators.
Right.
And they don't use TTYs, they use pseudo TTYs, so PTYs.
Wow.
So all of those terms, like there's a lot, like you will encounter them at some point, right? But PTY, essentially what you might just think about them is these are like TTYs, but they allow multiplexing, which is why your terminal emulator, which is the application that you're actually running, a terminal in a window. You can have multiple windows of that and multiple tabs in a single window. This is because PTYs allow for multiplexing.
Do you know that multiplexing was my first cool word?
What do you mean cool word?
I define cool words as words that you can drop in a conversation among software engineers, and then they will think that you know your shit. Like, so say like, oh yeah, I use a terminal multiplexer, and people are wow. So they don't ask you stupid questions from there, like the multiplexer.
Yeah, Tmux.
Yeah. But like Tmux is like, oh man, you just look at YouTube video that teaches you how to configure your terminal so it look cool. No. Terminal multiplexer. And then you do look port multiplexing. And wow, advanced network.
So what that enables you to do is this exhibit thing where you can have a terminal emulator using PTYs that is already a multiplexer, and you can run a Tmux inside that. So you can have a multiplexer in a multiplexer.
Wow, exponential multiplexing.
Right, and when you're starting a new terminal, the application that you're running there is actually called a shell, right? So that's the program that provides a command line interface.
Like Bash.
Like Bash or Z shell.
Or Fish.
Yes, which
or
has
Chrząszcz. Do you know Chrząszcz?
Chrząszcz, what?
Chrząszcz. I don't know if it's pronounced like this.
Yeah, Chrząszcz is a beetle in Polish.
I think it's called. I think it's not with X. It's like CH or something. So maybe it's Chrząszcz.
Yeah, it's the pronunciation is a little complicated.
Yeah, I'm sorry. We are Europeans. We don't know anything. Chrząszcz.
No, so actually being European, let me understand some of this early on. Since when I was researching why so many systems fail at representing my first name properly, I looked into UTF-8 and Unicode in general and learned that UTF-8 still embeds the prevalent ASCII encoding. So I looked into how that came to be, and I was somewhere in the 60s, but it was already based on pre-existing encodings that go all the way back to Morse code. So the first 32 characters in ASCII are not actually printable in the general sense of the word. So you don't have letters, numbers, punctuation, and white space. You have characters that describe things like start of text, end of text, end of transmission, backspace, or form feed, carriage return, and so on and so on. Yeah, you have things like some device control things inside that encoding.
Or beeping. That is a code that the terminal can do.
Yeah, exactly right. That's one of the early control codes that you have on the list. I think it's literally 7. And if you used a character like this in your ASCII text file, you might confuse your text editor like Notepad or VS Code that might not know what to do with a character like escape or the bell that you mentioned. Obviously, many control codes make sense in a text file, like line feeds used for putting new lines, or tab characters, and so on. But mostly this control code business was to inform a teletypewriter on where to put the head of the printer and how to move the paper up and down so that the messages made sense. And later on, we also got video terminals, which further enhanced what you could actually display, and people wanted to have sort of graphical interfaces with this. So with this came a wider character set and the ability to introduce color and, kind of inverse the background and have all other sorts of pseudo-graphical things that you might want to do with the terminal. So we introduced ANSI escape sequences, right? Which is, yet another extension of control characters. And that makes even less sense to a regular text file, so to regular input or output. So to process this correctly, we have to know that on the receiving end, there's not a text editor, but there's going to be something that understands the TTY protocol, right? So all of those escape codes. So for this, even if we are operating with standard input and standard output, there is a way with the TTY command and also internally with Python to learn whether what you're running is a TTY underneath. So in sys standard output, there is literally a method called is a TTY. And with that, you can figure out whether it is safe to use all those control codes to influence how things are displayed on the screen for the user.
Yeah, one thing that I want to mention here is that this is one of the most interesting realizations that people that learn how to code like start learning. The fact that when you say like, I don't know, echo in the terminal, there is so many things at the same time there, right? Because there is bash, assuming that's your shell, that has in memory the word echo, but that's not what you're seeing in the terminal. The terminal has basically, the keyboard has sent the keys, like the key codes for the keys to the device. The device has transmitted that to the TTY protocol, and the TTY has informed your terminal software to write and render those letters.
Right.
But those letters are not what is going to execute the command. That is bash that has also been informed that you have write echo. And there is a copy of that word, let's say, in bash memory that says like it's ready to go when you press enter.
Yep.
So that's why sometimes you don't get that output because it's being redirected to somewhere else. You can still like execute things.
Yeah. So interacting with the raw TTY protocol is somewhat painful. And if you ever tried this, you will know about all those crazy kind of codes that you send and you have to also handle when you receive them and so on, and how you need to enqueue them because there might be a flurry of activity in a very short period of time, and you need to do them in order since they kind of depend on one another. And if you do it out of order, then the result is not going to be what the user expected. So there are bindings to libraries that already handle this and handled for decades. And Python provides bindings for curses, a very popular library for textual user interfaces. These days, most users will opt for more high-level libraries like Will McGuigan's textual, which is excellent.
Yep.
But curses is what we have in the standard library, which is why it's something that we're going to be basing changes with our PR of the week.
Spoilers.
I guess. But before we get to the PR of the week, let's talk about how the REPL works today in Python. So if you say Python 3 right now and see the 3 chevrons, what is happening? Why do we have an interpreter that is interactive? How does that work?
Right. So normally when people think about REPLs, they think about this entire thing, which is a program that basically asks the user for input, and then it runs it through the regular compiler the parser and the compiler, and then executes the resulting code. And it's nice because it provides this beautiful, beautiful layer of abstraction when you can even implement new things like commands that only exist in the REPL, history, etc. So it's kind of cool. No? Well, it turns out that Python doesn't do any of this. There is no REPL, it's all a lie. I think we mentioned this in some episode, but CPYTHON is kind of like funky in this regard. So there is no abstraction. It's just like raw reality. It's just waiting for biting you. So the way the REPL works in CPYTHON is that it's basically extremely entangled with the parser and the tokenizer, right? It's not a separate thing. Like some people actually get very frustrated when they learn this because they think, oh, I just want to implement like this nice feature in the REPL, like, the holy grail of Python changes that you type exit and it exits instead of like telling you, hey man, maybe you mean exit and maybe you need to call this function because it's a function. So they were like, this is unacceptable. Well, you cannot implement that change because that will be implemented on the REPL layer, but there is no REPL layer. Oh no. So what it is this lie. So what the way it works basically is that when you start Python in interactive mode, the parser is basically told that there is no file, it's just a standard input. And then it activates this secret mode in which it asks you for input using a special library that we're going to talk in a second, which is called readline.
Yeah.
And basically we have a implementation using the readline library called in a file called myreadline.c that I have a suspicion about this file, Gukesh. I have a suspicion.
Yeah.
I think this file is still there from the first version of Python. So Guido wrote this. So I think that Guido wrote this file. The classic thing when you start like learning something that you call it my foo.py, right? And then it was never renamed. So now it's called my readline.c, and it's like it was never productionalized, right? And it's like the first version that he started, and it's still among us.
Likely, like my Py.
Do you have a Py? Yeah.
Yeah, MyPy was exactly like that, but MySQL wasn't. My is actually a first name of the daughter of the original author of MySQL,
Oh wow.
which is why
that's beautiful.
the fork MariaDB is another daughter of that same guy.
Wow. I'm amazed by this. This has given me all this warmth in my heart. Just in time to destroy by more parser knowledge. Okay, so let's go back to cold areas.
Let's go back to the
Mama,
darkness.
that's such a beautiful thing. I cannot lie. This is beautiful. I like it. I hope our listeners
I like it too.
it. Nice. Like insert some like sound effect of like warmth, like. Well, anyway.
And what do we have? REPL.
REPL.
Oh, by the way, did we actually say what that means?
Nah, never. But we are cool guys with multiplex. Why we'll need to explain.
Yes. So we will never explain that REPL is an acronym. You'll have to find it online to actually see what it stands for, which is...
the L is for loser. Well, anyway, so the REPL was basically implemented in this way in the middle of the tokenizer. Right now, because we receive one live coin every time we refactor the tokenizer, now it's in a different place. So this part is in different places on every Python version. Currently, it's in parser/tokenizer/readline_tokenizer.c. And half of it is also on file_tokenizer.c, because like standard input is also a file, like it has writes. So it's also a file. So it's there, and you will see there in all its glory where it's doing all these nasty things. And it's quite nasty because like the fact that this is still kind of like in the parser, it makes it extremely inconvenient, because the parser is trying very hard to treat the standard input the same way it treats a normal file. But you know what you can do in a normal file?
Seek.
You can seek forwards, you can seek backwards, you can parse it and then wait for it. You can go back to it. Wow. So you can say, I parsed this file and I created this code object. But if I want to see the source, I can go back because the source is still there. But you know what is not there, Lucas? What did the user type in? Because that is destroyed after it's parsed. That is quite bad.
Right.
So this actually made getting error messages and syntax errors in interactive mode in the REPL extremely difficult. In particular, many people are amazed by this fact, by the way. It's like they live in Matrix and they don't lie until there is like some cool person with like sunglasses that tells them this is the truth. They don't realize. So if you go to Python 3.10 and then you type, let's say, 1 divided by 0, and then you get a 0 division error, you don't get source. Like there is no source. Like there is no Python, nobody points to you that the error was in the 1 divided by 0, or like, you have a function that you type in the REPL, like, I don't know, def foo, and then you access a dictionary that is empty or something. There is no source. It just tells you like, bad exception, but it doesn't tell you what it is.
Yeah.
Quite bad. Not good. We don't like that. And this is because once we parse the code that you wrote, we throw away the source, because like where we can put it. Actually, I learned that a very common way to implement this particular feature of showing the source in the REPL is to have a secret file.
Oh, yeah?
The secret file where you write the thing and then you kind of like go back to that file that is temporary or whatever. And I tried that, but like it turns out that a lot of people are annoyed because you can execute Python in places where you cannot write files. So it's kind of like inconvenient. So it's quite hard. And also, like, you need to amount for like previous code, blah blah blah. So it's quite annoying to do it that way. But we didn't do it that way. So getting errors in general is quite complicated, and also because the parser is doing these things as you're writing stuff, and it doesn't know what is going to follow. It needs to do a bunch of weird hacks just to make it work. In particular, it needs to insert new lines that sometimes are not there. At the end of functions, when you finish the function and you press enter, like it doesn't need to press twice enter. So it needs to add like implicit new lines, something like that. And this make it quite difficult and sometimes even impossible to add new features to the REPL outside what the readline does. Because like when you enter, like when the parser needs more input from the user, instead of like just asking you for like, get me some characters, it calls this readline library. So most of the features that you can see in the REPL, like completion and like history and navigation and things like that, are implemented by the readline library, but not by Python itself. it's quite common sometimes when you go to some weird machine or when you compile Python to yourself that tab completion doesn't work or history sometimes is a bit funky. And the reason is because like the readline library was not available on the machine when you link to Python or because it's broken.
Oh yeah.
I don't know if that happens to you at any point, Gukesh.
Well, when we were working now, like on this PR of the week that for the time being will remain unnamed, we found out that my Python startup file was predating Python 3.4, so probably going all the way to Python 2.4 or so, where you had to actually set up your readline manually in Python startup because otherwise Python wouldn't automatically add completions and all this nice support like being able to use the left and right cursors. None of that would be there unless you had readline support. So you had to actually initialize it by hand by your startup file. So I had to remove all of this because now it was not only not doing anything, but actually it was actively harmful with our changes. But yeah, like I've been there where readline doesn't work. I've been there where you had to configure it yourself. And I've been there when we were choosing not to use it kind of consciously, because readline is a wonderful library, part of the new system, which is why it's released under the GPL. So when you're linking against the readline, boom, your project is now GPL. So not everybody is very excited about that prospect. So there are alternatives. Obviously, they're not entirely feature parallel, but there are alternatives like libedit, also known as editline, which, by the way, is something that relatively recently Homebrew on the Mac switched to building Python with.
Why was that?
So it used to build with readline, and now they are building with editline.
Oh, why they made that?
Well, because of the licensing differences, and kind of.
So how CPYTHON is not fully GPL then? Like if it's because it's LGPL that you can link to it and it's fine, but if you include it in the source, then it's not fine.
I think the entire reason why it was still like okay, it's not GPL was that this was an optional dependency. That you didn't have to build with this. So yeah, like, kind of if you didn't build with it, then okay, your REPL would be very annoying, but
it will be free of the evil license.
Yeah, it would work, right? Yeah, so readline is in fact extremely complicated as well. You would think, okay, it allows you to just, kind of move between commands up and down and have some completion and so on. So great, but also it has tremendously generic configuration called input RC, where you can do like
tremendously generic
set editing mode from Emacs like, where Control A goes to the left of the line and Control E goes to the back of the line. You can just throw it all away and say set editing mode VI, and then now you have model editing in your command line prompt. And there's other things that are in this configuration file where you can remap keys to whatever you want. You can create macros inside that particular, I don't know, I would call it a language, where you can just say, okay, if I have something on the left and on the right of the cursor and I press this magic key, those two things are going to get replaced.
Right.
Or I'm going to put braces around them, stuff like this. So you can configure rather advanced things with input RC.
The evil file.
Yeah, it was very surprising to me the extent to which you could go.
Lucas likes that file a lot. I'm quite terrified about like the syntax of this because I took a look for spoilery reasons you will learn in the next section. But like, man, you can do a lot of weird shit in that file. It's pretty long.
Mm-hmm.
Well, do you know what, Lucas? What is the funnier thing about this library that was half broken in Python 3.12 and nobody noticed?
Oh yeah?
Nobody noticed. Yes. Something happened as of this time that you are listening. Well, maybe, because of the time magic of the podcast, maybe a bit different, but like as of the time we are actually talking, we don't actually know what happened.
Yeah.
It's just broken.
Yes, exactly. Like we only noticed that, okay, there are things that it used to do and it no longer does. So
we don't know what happened. Maybe it was cosmic justice.
Yeah, I don't know. But like what we know for sure is that probably there aren't very many advanced users of input RC enough to actually
10x
notice
engineers in the input
that
ASCII.
the REPL of Python is now a little more primitive than it was before.
Well, to be honest, I mean, you mentioned this. There is also the fact that there is libedit and readline, and the fact that Homebrew changed to libedit, and like that doesn't read this file, right? So you cannot do these funky things.
Yeah, it has its own edit RC, which obviously is different syntax and it has different capabilities. So edit RC is funnier still because it is pretending to be like a shell. So you have commands in that configuration file, and you issue the commands. So when you have key bindings, those key bindings actually execute commands. But what are those commands? Like, those are not executables on your disk. Like, they're just some lib edit
internal
commands.
stuff, right?
Like it's all sort of weirdly, retro documented. It's just fun to discover like what you could possibly do with those things, like which nobody actually ever customizes anymore, I don't think.
Right. Well, but something that doesn't suck? The changes that we did in Python 3.13. This is not the changes that we're going to talk in the next section, but it's things that we have already done. Actually, we did this thing, as some of our listeners know, in the Python core, the core dev sprint, and we added source to the REPL. So now you can do like 1 divided by 0, and it shows you where it is, and like using also the funky like locations in the errors, you can show exactly what part of 1 divided by 0 went wrong. That's a very advanced feature. By the way, I think we never reveal how we do this magic trick. The way we do this is that there is this library in the standard library called line cache.
Yes.
And line cache basically is a cache of lines, basically, because every single time we go to a file, and because imagine that a function fail in file myfile.py line 62, and that happens all the time, right? So going to the file, reading the file, and like reading the source all the time is very annoying. So when it happens once, we cache it, so we can read from memory in a very efficient way. And also we handle things like the file has changed, so we invalidate the cache. It's very funny, but it's a perfect place because you can populate the cache with the standard input like code that the user is typing, or if you're using Python -c, you can execute some pre-given code, and it just works because the whole traceback machinery is told to look at that file, and if you pass the name of a file that is not a file, but the thing is already there, then it will use whatever it finds.
Interesting.
And that was all nice until... Well, someone reported that there is other things using line cache, in particular the inspect module.
Oh.
So inspect has this function called get source, and you pass a function and it's supposed to find the source for that function. Nice. It's actually very cool that we can do that, to be honest. Almost without decompiling or anything.
However.
Well, it turns out that for the interactive input, it's fine because we have free range, and we call the call objects interactive input, open angle bracket interactive input 1, close angle bracket, and then the second one is the same thing but 2. But Python -c, which is used by a lot of scripts in CI, uses a file name called angle bracket string close angle bracket. And then who else uses that particular file name for stuff? Everyone when they call exec, like data classes, like name tuple, everyone that calls exec for any purpose whatsoever, it uses the stupid thing. So when you pass down this thing to inspect, for instance, lambdas, then it gets you this funky thing because it's like, oh yeah, of course I know about the string.py. Well, the expected behavior is like, yeah, I don't know about the source because it was thrown away, right? So not good. So we are trying to fix this, and it turns out, man, I'm going to spend like 3 minutes talking about this because I was deeply traumatized. It turns out that this is stupidly hard. Like, I hated every single second of fixing this bug. It's still actually not finished to fix, but like we are close. The reason is because we thought, oh, well, it's very easy then. We just put the source from the REPL and Python -c in another cache. So there is 2 caches, and like the traceback machinery is told how to look at both depending and blah blah blah. And because file names are kind of like not good for automatically generated code because there is no file, or for like the REPL or by -c, we instead of caching by file name, we're caching by code object, which makes more sense. It's like, here's a code object, you give me the source, right?
Oh yeah.
Man, all the tests broke, all of them, because like now to query the cache by call object, the traceback machinery needs the call object, because before it has only the file name. So now we need to pass down the frame down. But passing down the frame means that the frame lives a bit longer, so a bunch of tests were failing because coroutine were keeping alive, because if you pass down the frame, then the frame is not dying and coroutines are not closed, and that was very annoying to find. And then, man, I just discovered that, we said, well, keeping the entire call object is kind of stupid, so why we don't cache it by the ID of the call object, the memory location of the call object? That sounds like a nice thing, like it doesn't allow full comparison, but that's a feature.
Yeah, sounds reasonable.
Yeah. So it turns out that all the tests in TestGDB fail, because the way TestGDB is done is that to inspect different objects, it has this script that runs ID on an object, and then it puts a breakpoint in built-in ID, which is the name of the C function, and then it inspects whatever standard output looks like. But because we were calling ID before the script calls ID, then it was the breakpoint hit our code, not the code that is in the script that TestGDB uses. And then instead of like the fancy object that is being tested, like an empty tuple or a list or whatever, it was code object at address 13469. And the error message for the test failing was so weird. Like, hey man, TestGDB failed because the empty tuple is not code object at 6341. Like, what the fuck is going on, man? So yeah, this is it. Like, come to the core team. It's fun. Like, you just want to fix the stupid thing that should be done, like a second cache, and now you're testing, like you're fixing TestGDB.
Fantastic.
Yeah, it's just very annoying.
Well, if you wanted to do a REPL from scratch, you would probably base on something that already somewhere deep uses readline or an equivalent, or any other terminal UI library like curses or urwid or whatever else, because just interacting with it by default is very complicated. So not using a high-level library like readline forces you to essentially implement all of those things like input RC and all those features that you have that you depend on, like moving to the start of the line, moving to the end of the line, deleting to the right of the cursor, right, which is Control-K kill with Emacs, and so on and so on. And you might even discover things that you never knew were possible, like we discovered now that if you do meta plus number, suddenly you see this new mode of the REPL saying arg5, and you can just say meta 5, and now it says arg55, and you can still press another meta 5 and it says arg 555,
and you will be like, what is going on?
What is this? So we can just say Q, and suddenly the REPL puts 555 Qs, because that's what the arg is. It allows you to just multiply things.
Man, this is very funny because Gukas is explaining like such a good teacher he is, but like we discovered this together the other day because we were like testing this new PR. And we were like checking features, and then Gukas like hit some random keys, and then the prompt changed to arg5, and we were like, what is arg5? What is this for? And at the beginning we didn't discover that it fucking repeats the key. We just like press enter and it disappears. It's like, It is nothing. Like, and I was like, oh man, maybe it's to get the fifth argument of a function or something that you have and then at some point we have like arg100. And you press T or something, and then it was the fucking screen with this. And we're like, why would anyone would like this? But when we discovered that it's not just about repeating the same letter 555 times, is that it composes with motions. So you can say, I don't know, delete 2 words. Maybe it's an Emacs thing. Maybe some of our listeners are Emacs users saying like, yeah, of course, arg5, like... That's how you move 5 words to the left or something.
Yeah. Well, we only discovered it now. Like, let me tell you, the text box in your browser will support Control-A and Control-E, but I really doubt it supports arg5. So in any case, like if you would want to re-implement the REPL from scratch, you have to actually do all those weird things and also do more typical things that you would want to do, like searching for previous commands. So obviously cursor up and cursor down are the easy mode, but you also want to have some search where you can input a query and it will return something for you, right? And if you started typing a command and you want to complete it with tab, that should also be implemented, and so on and so on. So you would be like, okay, cool. So how about we don't do this? We only use readline that we already have, and we use my readline C, right? And so,
my readline C.
Or maybe not my readline C, but maybe the actual readline C, which is our binding to the readline library that is a Python module. So you can use it from Python. So maybe use that. But readline.c is still .c. So you need to now actually implement all this string handling and also those magic codes in C.
The illegal language.
It's now illegal. You know it.
Yeah, illegal language. So not great. Plus, yeah, like even if you finish this, you would have to test it on both edit line and read line. And some of those things that we wanted would be really complex there. So in the end,
Yeah, can you imagine that we spent like 2 weeks making like, all these features that we want work based on readline, and then the homebrew people just switch to edit line and none of them work? That would be very frustrating.
Yeah, we would be very upset. That is true.
Yeah,
which brings us to what we are actually doing, which is stealing code, because
that's what artists do.
The best artists steal. Right. So let's talk about
The art of the week.
yes, the REPL of tomorrow.
The REPL of tomorrow.
It's written in Python.
In Python?
Yes.
The Python REPL is
Where
written in
did we
Python.
take it from?
Well, if you have a Python thing written in Python, it can only come from one place.
PyPy.
PyPy. Nice. It was military grade REPL.
Yes, it is used by PyPy, which is written in Python, but for it to be a little more of a curveball, PyPy is written in Python 2.
Yes.
It does support Python 2 and Python 3, but it's still a bit weird, which required some simplification and adaptation on our end.
Multiplexing.
So we're mostly through that part. Like, what are we working on right now?
We are fixing everything. Everything is broken.
Yes, so we're adding tests so that we actually do exercise this new mode.
I'm going to stop you here. Like, not pedantic Pablo, but complaining Pablo. Complaining Pablo is going to be our like feature of the day. So writing tasks for this crap is surprisingly annoying.
Yes.
Do you know why? Because like there is no easy way to emulate a terminal, because there is not a good way to say like, oh yeah, please spawn me a virtual terminal in any system that you can test CPYTHON, and I'm going to type a bunch of characters and I just want to look how it looks like. To be honest, actually, you can do some of these using textual. So it's like kudos to Will. They have made a very cool way to test textual app, but like doing this for the real like thing is surprisingly annoying, because like you cannot do like all of this, and like testing this requires you to have courses there, which is not always true, and like the courses database or whatever that is that we learned recently that is not available on ASCII.
Term info.
So even devising a way to test this in a non-insane way without having to like sponsor processes, it has been extremely annoying. So we have recently learned good ways to test this in ways that, because you don't want to sponsor processes either, right? Because like if you do that, then it means that when it fails, you don't really know where it fails. It just knows like it's a process failed, right? And then you have the output. So
it was really funny when we actually discovered that our previous assumption that we're testing anything was entirely wrong. So what we wanted to know is, are we actually using all the functionality in this PyPy REPL? Like Pablo removed a bunch of things we already knew we will never need early on, but later on we still had this sort of intuition that probably there are still things there that we could get away without actually importing to CPython. So we needed to check coverage, right? And our attempts to check coverage at first were like,
miserable.
There's zero coverage. There's no coverage. I am running test REPL. So it's...
Actually, I have no coverage, but you have some coverage.
Yes, but first I had zero coverage too, because it turned out that, if you don't actually run in a real TTY, it will all just revert to the old REPL. So our test REPL that we have in our test suite was just quickly bailing on any new code that we added and just running the old thing. So we were like, oh, this is amazing because it still works exactly like the old REPL because all the tests pass.
All of the tests pass. How cool was that? Which means that none of the tests pass. Well, I mean, they kind of do, but also I was saying that you have like some coverage because your startup script was being covered.
Yeah, so I didn't have 0% coverage. I had like 1% coverage, and it was my startup script.
You know something also that happened with me when I was reading this code, like to adapt it to CPython, because it's still like we are still talking that this is the default REPL of PyPy. So we say like, man, this needs to be some battle tested thing. But it turns out that, because PyPy is in a different situation than CPython, there is a bunch of things that we needed to change and things like that. So we needed to go deep and start changing some of the internal machinery. And we saw this file called like Unix terminal.py.
Unix console.py.
And man, that file is something. That file is something. So my first impression is like, this code is not good. Like man, this code is like written with hopes and dreams all pulled together with shrink wrap. But then after having living with that file for some very intense days, man, that code is doing the best it can. Like I wouldn't have written better code than that. Mm-hmm. Jesus Christ, man, this thing is complicated.
Yeah, like any sort of other library that does this exact level of abstraction, you will look at it and it just looks like some unknown assembler.
Exactly.
It is talking TTY.
_CUXY. And like, man, do you know what happened? I said like, oh man, this is stupid. We need to bring one of these cool like terminal libraries like Chrząszcz or like, the one that everybody uses.
Yeah.
And you open the library is doing the same thing and it's exactly as horrible. So there is no way to do this and having your hands clean, man.
Right, but yes, we are adding new tests, and I'm personally, because I'm biased, adding typing to this entire thing, which to be, a little bit smug about this, already found 2 bugs in the PyPy REPL. So yeah, right, like go typing.
Well, I mean, we have more than 2 bugs. We have 2 bugs using typing, but not using typing. We found.
Oh yeah, we also found other issues, but some of them are our different usage probably, and some of them are just Python 3 regressions. So when PyPy added support to Python 3, there were some, I don't know, like losses in translation, let's call them. Things that used to work stopped working because bytes are not strings anymore.
Yep.
And indexing a byte is an integer now, and so on and so on. So there are.
I have my favorite one there that is in that realm. So it turns out that one of the features you need to support is this idea of I suppose we need to explain why we're doing all of this, because like it seems that we are replacing the old REPL for the new REPL and nothing is going to change, but we need to sell the feature, because we're...
Yes. So first of all, we're doing it for Thea Flowers so that exit actually exits. Right?
We'll exit, man. Think about it. This technology, man. Like exit. We'll finally exit. But not only that, because dear listeners, Gukesh is very smart. And then I implemented this feature, finally exit. And I was like, over the moon, man. Exit. And then Gukesh told me, but what about if you assign exit to the value 1? Then it cannot exit. It needs to print 1. And I said, okay, I will implement that. I will do that. And then I did that. It's like, okay, now delete exit and then type exit, and it needs to exit. And I said, like, I know about your shenanigans, Gukesh, and I already implemented also that feature. So yes, you can now assign to exit, and it will print whatever you assign. But if no exit on the global namespace, it will fucking exit. Wow,
yes, that's amazing. But actually, what we mostly wanted, and what everybody wanted, and every time I started a REPL and started doing something non-trivial, I was like, no. We wanted multi-line
editing, yes. So you press up
that's
arrow.
Amazing.
And it brings the entire fucking function that you wrote, or the class, or whatever it is. And I think people will start writing bigger things because they are afraid that they are going to make a mistake and they need to like press up arrow 6 million times. And man, all these teachers, because you could say, man, but like don't use Python, we use IPython. No. Like, sure, yes. And be Python and all of that you want. But like, man, think about all these poor kids that are just learning Python these days. and they are like dealing with the REPL like for the first time, and it sucks. It's really bad that you need to press up arrow 6 million times. It's horrible. It's really, really annoying. Like not good. Like I developed the language myself, and I'm annoyed at this every single time that I'm doing a demo. It's very annoying.
So now you're being honest, because a lot of our external users, they're gonna be like, not a problem. Pip install Jupyter and I'm good, right? But when we're developing the next version of Python, especially early on, you can't really do pip install Jupyter. Like even basic stuff might not work for a while. So then all you have is the built-in REPL.
Yeah, not even IPython.
So having that built-in REPL be more awesome is a game changer for us. But I do feel like there's many external users, many end users who are also going to be using this.
Will exit, man. Isn't this beautiful? Also, there is more than that. You can also quit.
Yes.
So quit will exit.
You can also just say quit. And also, you can say help.
And help will show you the help.
Without the parents, and it will go into help, which is even better because now it has its separate history. So if you actually go, up arrow, like it'll actually have its own history of commands that is not polluting the history of your REPL when you're exiting help. So when you say quit to exit help, you will not have quit as your last command in Python anymore, and so on and so on. So history is isolated, and also history preserves multi-line input as well. So if you actually leave Python and return to it, you will see that there's still a function that is multi-line, which is
that's amazing.
Cool.
I had to fix that. That was one of the Python 3 to Python 2 problems.
In PyPy.
Because there's this funky thing when you have the file with the history, and then let's say that PyPy does this. Well, PyPy, the PyREPL, which is the REPL, does this thing when it says, I'm going to. You need to distinguish when the command ends and when the line ends, because you have a command that is made out of many lines, but it's still one command. So you press up arrow, it will come all of the lines together. So let's call it a compromise, shall we? So the compromise is that to mark the real end of the command, they use /r/n, which is this Windows funky
carriage return.
Yeah. So and it writes that to the file. And then when it reads the file back, it looks for where that it is, and it knows when to chop the command and not the entire line. So that works fantastically, except that in Python 3, if you use default arguments for open, it's going to transform automatically those stupid characters into just /n, because, Unicode and blah, blah, blah. So the trick doesn't work anymore. So if you go back to the REPL and then you press up arrow, then there is no multi-line history back. Oh, no. So you need to read the file in bytes, in raw mode, which gives you bytes, like in Python 2, and then you just manually split into the /r/n, and then you decode that. So it's a bit more annoying, but that doesn't work in PyPy. so we fixed it.
Yes, we checked. So we might actually report this and contribute things back. So it's not only Carl Friedrich contributing things to CPython, we can actually now give back.
We can be PyPy developers. Nice.
Huh?
Yeah.
See? Okay. Which would be like this small fee for stealing PyREPL.
Right. But let me tell you something. But they steal our entire standard library, right? They're smugglers. they smuggle the entire standard library, so we smuggle back the PyREPL.
Great artists steal.
Man, yes. It's all free, nobody owns the standard library. It's a product of modern nature. But let me tell you. Let me tell you something, dear listeners. We were doing this thing because we were oh man, we are so close to beta 1, the beta feature freeze, that we need to do this now, right? Because we cannot do it the last minute, because we have been all release managers here.
It almost is the last minute.
Come on, it's 2 weeks still. So we don't want to close it last day or even last week, because we are release managers. We know how bad that is. So we are going to try to do it 2 weeks before, because we are responsible.
If we wanted to do it with a week to spare, we should have done it last week.
When is beta freeze?
The beta freeze is in less than a week.
Oh, so we are not that good. Okay, my entire argument crumbles.
Yes, your argument fell apart.
Oh, sorry, Thomas. I hope you are listening to this. I'm very sorry. I thought we were going bad. Well, look, life is complicated, so we compromise here and there. But let me tell you something, dear listener. Just forget what I said. It's all ruse. So we we got into this like, oh, we need to fix all these bugs and get it ready to feature freeze, and the most smart thing that we can do is fix the bugs. And then Gukash entered this like feature spree mode. It's like, no, let's add color, and also let's add paste mode, and let's also have independent stories for like help and and the regular REPL. So now we also have all those things. Well, and let's add exit. That was also a feature requested by Gukash, and it made history because his decision changed the course of history. Because if Gukash will have not pushed me to add exit, that command will have never been implemented for 3.13, assuming that we get this into 30, by the way. But Gukash changed history.
I just felt like we need to have a good reason to replace the REPL, and that was always the most important reason.
Exit.
Multi-line editing, that's just extra.
Yes.
But the external reason to be good to the community was we want exit to exit. And the internal reason for me personally was that Python is not synthwave enough. Like it had already synthwave exceptions when, it was already
But
colored.
you just corrupt my ideas. I implement colors and you are, Pablo, that's kind of nice, but do you know what it would be great? Synthwave colors. Okay.
Yes.
And it's like, oh, here, look at this prompt, Gukash. Oh, that prompt is cool, Pablo, but do you know what it will be better? Synthwave prompt.
Joking aside, those colors just happen to have equally high contrast on light backgrounds and dark backgrounds.
So you're slowly using our work to transform Python into your synthwave project.
Now everybody's going to know if they are using the new REPL or not, because they're going to just see this graphically.
I agree
and
with
also,
you. It's cool
the
that
prompt,
you see the chevrons.
The funny thing, which is funny but also scary, but also funny, is that readline is evil. It is a global state inside your application.
Not good.
Right? Like you configure it once, there's no nice object. You cannot have multiple ones.
Exactly.
So once you configure readline and you read that input RC and all of this, it's there. And if your Python code calls other Python code that also wants some readline input, it's going to use the same global state. And it gets better. Readline also monkey patches input.
The input function.
Yeah, so our prompt coloring now caused a funny effect that help, its prompt also is colored. If you call PDB from the new REPL, that prompt is also colored. It's a color all the way down.
By the way, you are because this is a podcast, you cannot see my terror expression right now, but I just realized if we are this is a bug, like free discovery, live discovery. 1 second, if we are monkey patching input to make readline work, it means that if you call input in the REPL now, it's going to use our multi-line bullshit.
Yes.
Oh. Maybe that's not good.
No, like, so this is fine, because for this to actually activate the actual processor of the input, which is somebody else's code,
Right.
would have to still say, okay, we're now in line 2.
Okay.
Because now it doesn't know. Like every time you actually press enter, it's like, okay, input is done. Because like that kind of magic parsing of Python, which is like, oh, we're on line 2 or line 3. That's not happening.
That's
So we're good. Like there's no bug. You would see that you cannot leave help. So like
well, but okay, but then let me talk about something that we know that is happening and we have not actually fixed yet. So Gukash posted this cool image in Twitter, like making himself like interesting. It's like, oh, what about this? This is not Python. What is happening? Follow me. So then Will from Textual appear, and this guy knows 1 or 2 things about terminals, and he said like, what about, no, he said like, does this work with like, what is
CJK input?
Yeah, like Chinese characters and whatnot. And I said like, well, I don't know, it kind of works, like, you paste the thing and it's just there and it prints and it works. But if you move around with the cursor, it does some funky shit.
Yes, because those characters are double width. So you move the cursor and you see where it is, but it's actually not where you see it.
Exactly. Yeah. And by the way, this problem also happens in PyPy. Like you open a PyPy prompt right now, and then you paste like Chinese characters, and then you paste a space, like adding spaces in the middle. They will slowly disappear for some reason.
Yeah, so that's our bug report number 2. And when we implement a fix, like we will upstream that fix. So yes, the world will be a better place on both ends, I guess.
Yeah.
Yeah, there are some remaining kinks to be worked out, but we're getting there, so it's pretty exciting. This is obviously only available if you have curses and when you are starting the REPL inside a TTY. So if those things are not met, you're still gonna get the old REPL.
Right.
And on top of this, we also will want to have an environment variable that will just force the old REPL on you when you want it, because
For the nostalgic people.
yeah, if you are a hardcore user of input RC that got heavily offended by us saying nobody uses this thing.
Bro, did you even multiplex?
Yes, and you're like, no, I am actually, my input RC is 700 lines. So you'll be able to still have the old REPL with your customizations.
Right.
And probably VI mode, right? Because that's probably the only customization that might be actually in use.
Right. Okay, Lucas, tell me something funny that you learned like hacking this PyREPL.
Oh, okay. So just for some little context, how I got there, which is a little weird, was we wanted to be able to paste multi-line input. But to be able to paste something, you have to first copy it from somewhere. And I was like, I cannot copy it from the REPL because it has all those chevrons. Wouldn't it be cool if we had also like a mode in the REPL where you can only see the commands as issued without the output and without the chevrons? So we need to have some pager that will just show us the history. So we can actually copy something so I can then paste it and test that. So I was like, I know there is something that is already using a pager in Python, pydoc. So I go, and for the first time, I think ever, I'm looking in pydoc source code, and I see all those pager implementations that, you know, deride windows for like not supporting pipes properly and whatever. I'm looking through this. I'm like, okay, we need to copy this because we need to actually use this pager thing. But I keep scrolling, and I find
The secret.
that pydoc has an HTTP server inside.
Jesus Christ, oh boy. Why there is an HTTP server?
You can run pydoc and display it in HTML mode, but it would be inconvenient if you had to actually put this into files and then start a browser and whatever. So you can have an HTTP server and then just go with your browser and look at pydoc with HTML, which is obviously HTML you probably never have
So
seen.
it's like okay, so this will be equivalent to like Clang, the compiler is giving you the output, but you can also choose to print HTML instead. So let's ship an HTML server with the compiler, so you can actually look at that HTML without opening it in the browser, right? Like, that's what you're telling me.
No, it's funny because pydoc is a separate command, right? So that's why it does this. But and there was already a base HTTP server in the stand library, so all it took was just to extend it, and
Well, I cannot wait for next CB security issue in Python. Hackers use pydoc to hack into the White House using secret HTTP server.
Actually, it rings a bell that there was at least one thing related to pydoc that was a security vulnerability by somebody, but I would have to look. Now I cannot remember off the top of my head.
And core.py is involved in the hack. We are learning from them how they
that one was something about the fact that if you run pydoc and you typed in some kind of confused config parser or whatever else, then somebody might have changed that file to be something else and it would execute code or something like that. Right. I can find this later and we can say in another episode what that was. But yeah,
let's do that.
pydoc. Don't use this in production. It's not safe.
Well, unless you need an HTTP server, maybe you can use pydoc. Why use Flask or Fast API when you can use pydoc?
Yeah. Especially that pydoc has this sort of special documentation that, it's helpful sort of if you are already in the interpreter, but I don't think these days most people add much to PyDoc in terms of actual content for this. So you might have things that are just doc strings which just happen to be useful for a bit, but not any specific content is being added there now. So it's seen better days now, especially like that HTML output. Like I don't think anybody looked at this in the past 10
maybe
years.
heavy users of input RC will also be heavy users of the HTML output.
Right. We are past the hour mark. So let's leave HTTP servers.
And let's talk about
what's
going on
in CPython.
All right.
Right.
So let's start with the biggest feature of Python 3.13 that probably everybody's waiting for. And they're going to have to wait for a bit longer for what they actually expect from the feature. So first of all, Brant Booker knows how to live his life. First, he lands the feature and then he's like, okay, you wanted a PEP? You wanted to discuss the feature? Okay, now we can do it. It's already landed. It's already happened. So now let's write a PEP. So he went and wrote PEP 744, a great number, by the way, and marked it informational. He's like, yeah, there's nothing to discuss. Like there's not going to be any
done.
decision.
I mean, to be honest, hello, Brown. We know you listen to us. Thank you for sharing this speech with us. So, I mean, to be honest, the Steam Council and Thomas asked for the PEP. So it's not that he decided that, I'm just going to write a PEP afterwards. We said like, okay, maybe a PEP is needed because, this is such a big change and it is some compromises, especially around the debugging that and he wrote like a beautiful
Cool. I'm being cheeky here, obviously. But at the same time, I did expect that it would be at least a PEP that you can then stamp and say, okay, official steering council approval.
It's done, but
and Brant was like, no. Informational.
This
thing is a
also
done
fun
deal.
because I'm Brand, like all of this is a joke, so don't get mad. But like one of the things that it was interesting with the whole JIT is the debugging story, because like the GDB doesn't work with the JIT, right? So if your Python crashes because there is some segfault on a C extension, or like NumPy crashes, or the TensorFlow crashes, some of those things crash, like then good luck if the JIT is active. So there was like this conversation around like, all the debugging thing, which was very fitting for a PEP because, everybody will have a different opinion and it will be hell. But marking it as informational and saying in the PEP, I think the sentence is like, some people that know more about this should make it work. I mean, it's better written than this. Obviously, Brand is such a nice guy, but like, it basically says, we are probably not going to, they say it's not a priority right now. But the fact that the PEP is informational is like, by the way, I told you it's not a priority. So it's like there is nothing to do here.
Yeah, so to be clear, profiling and debugging like kind of remain unchanged from the Python perspective.
Yeah, it's only...
But yeah, if you're doing C code tracing, you cannot trace through JIT frames at this point.
I mean, they made a good point, which is that the leaf frame will be there, which is how they debug the JIT. So the place where it crashes, the name of the function will be possible. Well, I mean, the JIT is not a function, but the last one will be, but like the call stack will not. So it's not possible to know where it's coming from, and profiling won't work either.
In case you haven't actually read the PEP yet, the gist of this is this: we have the JIT implemented for all tier 1 platforms. So that's Linux on Clang, Linux on GCC, macOS on Clang, and Windows on Microsoft Visual Studio Compiler. All of those are both on Intel or AMD, right, 64-bit, and on ARM 64-bit. So that's already nice and broad support. There are some new platforms that might even kind of raise to tier 1 at some point that might never get JIT support, like WASI and iOS.
Right.
Those might not be there because iOS doesn't allow you to run JIT code because, as the PEP itself says, it is a bit of a security risk, because if somebody can get to your memory and put other code there, well, that code is going to get executed. So you have to be careful to not allow too broad of an access there. And obviously all the other memory access vulnerabilities might be kind of abused to interfere with that, which is why iOS doesn't allow it. For whatever reason, macOS on much stronger machines does. I don't quite
but
understand.
you need to mark it with the bullshit
Hardened,
Apple. You need to, when you release it to the Apple Store or something like that, or like something like that, you need to mark it with a special capability. Like for marking memory sections as executable and mapping that, you need like a G blah 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 capability. So we need to apply for that or like mark it or something.
Yeah, cool. But like that could be also possible on the phone, right? Like, what's the difference? So kind of for whatever reason, Apple decides like iOS is out of the question, at least for now, until the European Union sues the hell out of them. I don't know.
Allow JITs in Europe.
Yes, maybe JITs are only going to work in Europe. Yeah, another platform where you cannot really do this is Wazi. So we'll see. And even for now, if you enable this, which is marked as experimental, you won't see much difference because the current level of performance is about the same as our specializing adapter interpreter, which is now the default. So it's that doesn't sound like a great win, but it is actually, right, with the amount of change that was necessary to actually get there. And brand plans to, on the market as experimental, to actually make this the default, like when we cross 5% performance increase and higher, like at that point, this will be proven worthy, because obviously all this complication in the internals is motivated by performance. So we are tracking an issue where the improvements are being implemented. So you can go, it's GitHub 115802, where you can already see there's a bunch of ideas implemented and more coming to make things faster. But many of those will not reach Python 3.13. So for 3.13, the JIT is experimental.
Right. So another thing, talking in the faster Python realm, is that if you recall from some previous episodes, we have this open saga of Mark Shannon fighting the GC. So he finally won. And we finally have a PR that was merged that implementing incremental collection in the garbage collector that doesn't crash the big mem billboards that was doing before.
Oh, it didn't crash. However,
the GC has always something else to say.
Yeah.
In particular, it introduced quite a big of a performance regression, quite difficult also to spot from the first time. But in particular, it was introducing quite a big of a slowdown with large list comprehensions that are creating cycles all the time. In particular, it was 20 times slower, so not good. So this actually forced Mark to change a bit the way we do like full collections. So instead, basically, the thresholds that when we decide to do a collection or not was based basically on the number of survivor objects in the young collections. But that obviously doesn't work for if you're constantly creating cycles or if your GC runs are constant cycles. So there's new strategies that the collection is done in 1% incrementals. So instead of being on a fixed number of survivors, it's based on the size of the generation.
So this is interesting because it ends up being a little similar to how we did it before. Because before we were every 100 young collections, we did a full heap collection. Right. So now it's like if you're doing 1% all the time, like, well, in the end, it's similar, but it's more stable.
Right. So essentially, we are performing like a whole heap collection. Well, heap is not the whole memory because we don't have a tracing GC. It's like the size of the generation. At the same rate as the cycle collection is that, but we do it in increments. That's the main difference. It's like almost like the GC doesn't really like changes. But yes, this was not easy, and he managed to pull it off. So now we are having we can close this saga. The issue is still open, but it's because we still need some documentations here or there and what's new entries. But that is done, and now we have incremental collection. So this will be seen in 3.13.
Very nice.
Cool. Also, for in the faster CPython realm, we have the tier 2 counters, and this is the counters that are used by the tier 2 interpreters when reaching thresholds to activate these different things. So have been re-implemented by Widow and Rosen using a unified 16-bit backoff counter. We call it Pi backoff counter because we are very original. Underscore because it's private. You cannot use it. Maybe Python is saying like, private, I don't care about those underscores, man. I can use it. Well, anyway, the advantage here is that this uses less memory because it's 16 bits. instead of 32, and it's slightly faster on average because it's 16 bits instead of 32. Because it's such a small micro optimization, to see the actual improvement, you need to run like most heavy benchmarks, like micro benchmarks in PyPerformance.
Yep.
So nice, very very good, very good. Another cool thing that is quite nice to see actually is that the number of micro ops that we can handle in tier 2 is steadily increasing. We have things like return generator and for iter gen and resume check as the latest additions. Some of these are actually implemented by new contributors that are very excited about adding this new micro ops, but also as the long-time contributor for faster CPython.
Nice.
And then the one change that I'm sure, like we in our note, we have not annotated who did this change, but I can already know that it's Mark Shannon, unless Lucas surprise me otherwise. Like halt and core parts of the code templates that we have for the JIT have now been splitted, which will improve the JIT code quality. Just because there is 2 different regions, one of them is more visited, so it's kind of more heavily. And I know it's Mark Shannon probably, maybe it's Brad, but like I think it's Mark. The reason is because Mark loves this splitting hot and cold things everywhere. Like he's pursuing that.
Yeah,
it's true. I mean, it's not on vain. Like this is an actual thing that will speed up things. But he's very adamant when sometimes it's not that useful. But I'm sure in this case it is. It's just that I was surprised. And I will be surprised if it's not Mark, the one proposing this.
right. One platform that is not going to see much win from those changes is iOS, which Russell Keith McGee worked very hard to bring to CPython. So now pip 730 is implemented. Python is officially supported on iOS now.
Nice.
And this is pretty amazing because there are a bunch of limitations of this platform that we didn't mention yet in this episode that had to be overcome. So now you'll be able to kind of access the information about your running platform from platform iOS ver. There's new entries in sysconfig. The web browser module does the correct thing.
Do you mean the PyDoc module?
Well, also, yeah, maybe the PyDoc HTTP server will work. I don't know, actually. But the most important thing, and PyDoc would also actually depend on this, is that dunder file on iOS is misleading because by default, you would learn where those binary modules live. So every binary module actually has to be its own so-called framework, which is essentially like this, artifact on iOS and also on macOS. So all of them are separated in different directory trees, and they have different kind of security modes and so on and so on. So knowing dunder file of a particular framework would be entirely useless for you to look for other data files and so on that lie around in your distribution. So what Russ did was to still lie to the user, or lie to the user code, which is say where that dunder file would be when if there were no frameworks. So that made a ton of code just magically work with no changes. You could argue that code that depends on dunder file specifying where your data files are is currently broken already because it should use something else like import lib resources or whatever.
Right.
But in practice, a ton of people are just using path-based operations to get to their other artifacts and so on. So now like a ton of tiny changes that summarize into Python being officially supported on iOS. Those things are done. So I'm very happy to see this. It's going to be much easier for us to embed Python in applications that land on your phone.
Which is fantastic and it's a lot of work. So thanks a lot.
Yeah,
Right.
Congratulations.
Yep. Another change that I'm very excited to talk about that was made recently by, recently, like this PR has been open since January, I think, because, quite a big review. But this is a change made by Santanu, which is the maintainer of typeset and MyPy. You probably have seen it around.
Yep.
And this is to show a better error message when a script shadows a standard library or third-party module, which I think is something that has happened to everyone. I think, for instance, that you have
I did it today.
Today. Okay, that is wild. Well, this is the case just for you listeners. Is basically if you have a script called random.py, that happens to be the same name as a module in the standard library. And then your script normally takes precedence. And when you try to import some function, let's say run int, then it says, yeah, you don't have that because your script probably is not implementing that, and everything breaks. So now, when we show you the error, normally it's an attribute error because you're missing like something. And we detect this case. Now we show you as helpful tip that says maybe consider renaming home random.py to something else because that is a standard library module. So especially for newcomers that have never seen this problem and it's very difficult to diagnose, this is such a big difference. So congratulations.
Yeah, the thing that I added today was a types module to the PyREPL package. So it isn't technically shadowing anything because it's
PyREPL types,
_ PyREPL.types. So it's perfectly fine. But if you're running MyPy by default with no configuration file from that directory, it will be like, oh, this actually is shadowing the standard library module. So it was unhappy with me for a bit. Right. I had to add a MyPy any configuration file to actually say, no, this is the root. This is where you live. So this is a package. And then it was, okay, fine. Types are coming to PyREPL. But what I wanted to talk about is queues. So as a poll, I was brought up queuing up for a lot of things when I was little with my mom and so on in communist times. So queues are dear to my heart.
What is happening? What is happening?
Laurie O from Australia was concerned about a feature of queues that I always just thought about as just a fact of life. That, hey, if you have a queue that no longer accepts anything, but you're blocking on getting an item from it, how do you know that you can actually exit, that you can stop your application, that you can just shut down? You don't know. You will never know. So you need to have some magic last message being sent through the queue saying, we're shutting down. But those things are a little bit fragile. And also the opposite is true as well. If you have a producer that is also blocking when the queue is full, but that queue is no longer actually accepting anything, you will block forever. And you don't know that it is safe to actually shut down. So now the async IO and threading queues have a new shutdown method that allows this communication to happen, that this queue is now defunct, it's now closed, it's not accepting any new items, it will never produce new items. Multiprocessing was another candidate where there's also a queue there. We could also extend it with a shutdown method, but it turns out the change in behavior requires a new API. And since no consensus was reached in time for 3.13, this will have to wait until Py 3.14. So eagerly awaiting this, but congratulations on shipping async IO and threading queue shutdowns.
Nice. One other change that is quite good is that thanks to Peter Victorin, which has been working a lot in this particular field, ctypes that are static types and the metaclass are now heap types. Wow, so that's such a mouthful. So this is a change that is for the ones in our listeners that don't understand what this means. This is a change in the way this is implemented internally in the C API. So it's the time of how it's represented in C. And this basically, the reason we're doing this is because this provides better isolation and allows these things to work in multi-phase initialization, which is required by things like sub-interpreters and also to some extent no-GIL.
Yep.
This is also, there's some changes that need to be done here because we have been changing the internal structure there, in particular for the one that know about it. It's a special slot called tpdict that is basically, implemented a custom dictionary in those types that have to be removed in some of the classes, particularly stitchdict that was overriding it. But yeah, so that change basically is quite good because now in the future we can switch, or now we can switch C types to multi-phase initialization, which is much better.
You heard it, right? You heard it.
What?
A steering council member said no GIL.
No.
That happened. Yes.
No, you need to change the Lucas. No, I cannot lose my credibility.
Since
No.
Since that was already mentioned, you would think,
no.
what? is Łukasz not going to talk about free threading? No. I have an entire list of things that happened since our last episode. So let's go. So first of all, there's a bunch of new things that were made thread safe, like the ABC module, sysset trace, sysset profile, and sys monitoring. Like that's thanks to Dino Wieland. So awesome. Instance attributes stored in inline dicts are now thread safe as well. And deferred reference counting is now mostly implemented. Mostly meaning, well, it's a very complicated feature. It is there, code objects already use it. Temporarily, objects that use deferred reference counting are immortalized to avoid scaling bottlenecks, but we're getting there to actually getting all of that done. Sam Gross is spearheading that. Thread Sanitizer is now added to CI to find thread issues, and it's already been helpful in discovering a bugged indict object.
Right. Yeah.
So good. Thread Sanitizer is kind of hard to set up such that it doesn't raise any false
I
positives.
would even say impossible.
And the test suite now sports a requires GIL enabled decorator that marks tests that won't work without the GIL, and that includes the tests of the GIL. So now those tests will not work in the free-threaded Python because that is kind of silly.
Well, and the last thing that we have here, which is quite cool, like we go for a circle over how Nate Apples fixed this problem actually, that data classes are now created a bit faster because now instead of calling exec, basically every once per method to create the different method objects, all of those are batched into one single call of exec per class, which is much faster because you avoid like going to the compiler many times, which is a very similar trick that I think, if I recall correctly, we did in named apples. So yeah, that is quite cool. And it's also the last item that we have in this section.
Right.
And we are only at 1 hour and 23 minutes.
Such a short episode.
Yeah, almost it's gone. Like if you are commuting to your work, then
If you are still commuting and you started listening at the start of the episode when you started your commute, like we are sorry. We're really sorry for you. Like no, your commute shouldn't be 80 minutes. No.
maybe you should push for some remote situation. Yeah.
But speaking of commuting, soon enough we're gonna be traveling to Pittsburgh for PyCon.
PyCon, nice.
Yeah, both of us are going to be there. We have our talks, but we also have a talk together, which is going to be a special episode of core.py on stage.
Wow,
So,
live.
you should come and see all the shenanigans.
And I can be
we might
there.
actually land something in Python then, just for kicks.
So join us. People call these days these kind of things fireside chats. You know, like you are
Fireside
you're
chats,
close to the
yes.
fire. Yeah, cool. Join us in PyCon. If you're attending PyCon and you want to see the internal workings of core.py, which is about the internal workings of programming language, join us. You will be amazed at how stupid we are also in person.
Join us for our trash fire chat.
Trash fire chat. Well, we'll see you next time.
See you next time.